This is question 14 on exercise, was it 5.3, wasn't it? So we're asked to finish this one off here. So look, what we're going to say is 2 to the x plus 2 to the x plus 1 plus 2 to the x plus 2 equals k times 2 to the x. Now, some number multiplied by 2x. What we're going to do is we're going to change this one into 2 to the 1 by 2 to the x using the addition rule. Then what it's going to be is 2 times 2 to the x. So we're going to have 2 to the x plus 2 times 2 to the x. And this one here is going to be 2 squared times 2 to the x, which is going to be 4 2 to the x equals k 2 to the x. Okay. We got 1 2 to the x plus 2 2 to the x gives you 3 2 to the x. 3 plus 4, 7. 7 2 to the x on the left. And if it's 7 on the left, what is on the right? Huh? 7. So k equals 7. Seven, 2 to the x, okay, because it's 1 plus 2 plus 4, which is 7. Actually, probably one of the easiest questions in the whole thing. Yeah. For part 2 of this question, we're asked to do is hence solve the equation 2 to the x plus 2 to the x plus 1 equals 2 to the x plus 2. Well, what we're just after saying about all this is that it's 7 2 to the x. So 7 2 to the x equals 224. What is 224 divided by 7, anybody? 32. Cheers. 2 to the x equals 224 divided by 7 to the power of x equals 32. 32 is 2 to the power of 5. This means that x therefore must be equal to 5. Okay? It's good. Okay. Any questions on this one? This exercise 5.4 question 3, okay, and the way they want these ones done is the following. It says for all n element n, for all natural numbers, this means n is only allowed to be the number 1, 2, 3, all the way up to the biggest number you can think of. It's not allowed to be a fraction, it's not allowed to be a decimal, and it's not allowed to be 0 or negative. Okay, find in terms of n, u of n plus 1. Well, to get u of n plus 1, all I need to do is anywhere I see n, replace it with n plus 1. 2 times 3n plus 1 minus 5 into 2 to the n plus 1. Okay, now I can change this. I'm going to change it into 3 to the n's. The reason why I know I'm going to have to do this is I'm going to have to prove that they're all equal to 0. I've done these questions before, so what I'm telling you now is when you see a verified question that has u of n plus 2, u of n plus 1, break all of them back to the way they were originally. So what I mean by that is, see the way it's 3 to the power of n? You can't really add 3 to the power of n plus 3 to n plus 1. They're not really compatible, but I can make them compatible by changing 3 to the n plus 1 like we did in the last exercise. So I'll show you what I'm going to do for these ones. What I'm going to do is this. I'm going to keep 2 where it is. The number 2 exactly where it is. I'm going to change this into 3 to the power of 1 by 3 to the power of n. Is everybody happy with that? Minus 5 times 2 to the power of 1, 2 to the power of n, using the multiplication rule. Now, I can multiply 2 by 3, and what do I get? 6 multiplied by 3 to the n. Can I multiply 6 by 3 to the n and get anything? I can't really get anything because I don't know the value of n. Okay, done. Next one is 10 bracket 2 to the power of n. That's the way it turns out for u to the n plus 1. Now we got to do u to the n plus 2. Replace all n's with n plus 2. 2 brackets 3n plus 2. Close bracket 5 bracket 2n plus 2. What do I do this time? Anybody tell me? 2 multiplied by, what goes in here? 3 squared, 3n. What about this one? 2 squared, 2n. Okay. Now, what do I have now? What's 3 squared, anybody? 9. What's 2 squared? 4. 2 times 9? 18, 3 to the n, minus 20, 2 to the n. Okay? So that's that's part 1 done. Okay, just only part 1 done. Okay? Now that's done, okay? What we're going to do next is, I need to make that slightly bigger. Okay, it's perfect. Now guys, I got to do this part here. un plus 2, 5un plus 1, 6u to the n. So here's a question. Hence verify that, James, hence verify that u of n plus 2 minus 5u to n plus 1 plus 6u to the n equals 0. So here's what I have to do. Write down u to the n plus 1, or sorry, u to the n plus 2, which is in black. Okay. Then the next section of it is going to be in red, the 5u to the n plus 1. Minus 5 bracket u to the n plus 1, which is 6, 3 to the n, minus 10, 2 to the n. And then the last section, which I'll do in green, is going to be, just the green section here, it's going to be plus 6 u to the n. So it's going to be 6 times 2 to the 3n. I'll obviously have to, excuse me a second with this. Just beware of space with these ones, because you actually tend to run out of space a lot. 2 to the 3n minus 5 to the 2n brackets. Okay. Now here's what's happening. This stays the same. 18 3 to the n minus, sorry, close the bracket there. 18 3 to the n minus 22 to the n stays where it was. Now what's 5 times 6? 30. Minus 30, 3 to the n. And after that, plus 50, 2 to the n. Okay? Now what's next? Plus and 12, 3 to the n. Minus 30, 2 to the n. Okay? Now what's happening here, guys, is the following. Take out 3 to the n. Now what numbers go beside 3 to the n? There's 18. There is plus 12. And then there's no, it's 3 to the n. 3n minus 30, sorry. That's all the coefficients of the 3 n's, isn't it? I'm factorising out the 3 n's, haven't I? So look, for those of you who are struggling with that last step, this is basically what I'm doing. I'm putting anything that has 3n next to each other. So I'm going to do 18 3 to the n. I'm going to put minus 30 3 to the n. And then I'm going to put plus 12 3 to the n to the left. And then to the right of that, I'm going to put all the 2 n's. So minus 22 to the n. And then I'm going to have plus 52 to the n. And then minus 32 to the n.
What's this supposed to be equal to?
It's going to equal 0. Okay, so what's going to happen is, then I'm going to factorise out the 2 to the n. I'm going to put plus 2 to the n. Now, it's minus 20, plus 50, minus 30. And that all has to equal 0. Now, what happens here? 18 plus 12 minus 30? 0. Minus 20 plus 50 minus 30? 0. So it's 3 to the n times 0 plus 2 to the n times 0, and what does that equal?
0.
0 equals 0. It's always going to work out that way. But I have another one of these to do, so don't worry about it if you're not getting it just yet. Okay, try another one. Number 7, okay? For all natural numbers, n u of n equals n plus 4 times 3 to n. Show that u to n plus 2 minus 6u to n plus 1 plus 9u to n equals 0. Please pay close attention here. U to the n is n plus 4, 3 to the n. Now how do we do u of n plus 1? Replace n with So it's going to be n plus 1 plus 4 is n plus 5. And that's going to be 3 to the n plus 1. Break up 3 to the n plus 1. What do you get? N plus 5 times 3 by 3 to the n. You're allowed to multiply these two, aren't you? Because there's no, remember BOMDAS, okay? This one here has a power. That's why you're not allowed to multiply that one in. But this one here has a power of 1, so it's allowed. So I can just multiply that out, and I'm going to get 3n plus 15 times 3 to the n. Going to stop there. Okay? Next one I'm going to do is u to the n plus 2. Once again, very similar. What's the start off? Was n plus 4, now it's going to be n plus 6, because that's n plus 2. And then it's going to be 3 to the n plus 2. Break it up. N plus 6, 3 squared by 3 to the... Now what's 3 squared? 9. What's 9 times n plus 6? 9n plus 54. 3 to the n. Stop there. Now what we have there is we have exactly what we need for the next part of the question. Okay? Or part 1 even. So what I'm going to do next is u to the n plus 2. We'll go write that down first. U to the n plus 2 is 9n plus 54 multiplied by 3 to the n. The next one is minus 6 multiplied by u to the n plus 1. What's u to the n plus 1? 3n plus 15 3 to the n. Close brackets. Alright, and then finally plus 9 times u to the n. 9 times where is that? N plus 4 3 to the n. Okay, look at these now, okay? I had to prove it equals 0. So here's what's going to happen. Here's what's going to happen, guys. We're going to multiply everything out here. Okay? Now, actually, sorry. You could multiply everything out, but it might get a bit sloppy. So what we could do is, we have a choice. If you decided to multiply everything out, you wouldn't be wrong, Connor. Okay? So, but what I'm looking for you to do is this, okay? Multiply 6 minus 6 into there. Okay, and what happens? We're going to have 9n plus 54 bracket 3n. And then we're going to have, we'll just use a plus bracket just for the sake of it. What's minus 6 times 3n? Minus 18n. What's minus 6 times 15? Minus 90. And that's bracket 3 to the n, isn't it? Now, what about the next one? 9n plus bracket 3 to the n equals 0. Now what do you notice about every single one of these? They all have a what in it? 3 to the n. Now lads, the way you can do this is, it's very similar to this. Are you looking? It's very similar to this. If I had 9y plus 5y plus 3y, I could technically write it like this. Y into 9 plus 5 plus 3. I'm going to do the same thing here. I'm going to take out 3 to the n. And look what happens when I take out 3 to the n. I'm going to have 3 to the n, big bracket, 9n plus 54. Then I'm going to have minus 18n minus 90. And then I'm going to have plus 9n plus 30. Close bracket equals 0. Need to prove that this part here in the brackets is 0. 9n minus 18n plus 9n cancels. 36? Yeah, sorry. 54 plus 36 cancels out to minus 90. It's going to be 3 to the n times 0 equals 0. There's no quicker way of doing them. You just got to bash it out. Okay? Now, next part. Yes?
Just you jump up to the very slash. Where are you getting the UN plus 2 H of that?
I have question 7 I need to get done here, okay? Shane. So again, Chris distracted here, Shane. So guys, next one is for what values of n greater than equal to 0 is u to n plus 2 greater than 4 bracket u to n plus 1 minus 6 multiplied by 3 to the n. Now, what's going to happen is we're going to put in u to the n plus 2, and we know that's 9n plus 54 to the power of 3n. Okay, the next one is it's greater than 4 multiplied by u to the n plus 1. U to the n plus 1 is 3n plus 15 u to the n, or 3 to the n. Okay, I'm just doing this part in here, guys. See the part I'm underlining in red? I'm going to do this all here, starting off. Now, what's minus 6 multiplied by 3 to the n? It's going to be minus 6, 3 to the n. Multiply this out, and what we're going to get is 3n, 3 to the n. Remember, normal n and power n. 15 by 3 to the n is going to be plus 15, 3 to the n, minus 6 times 3 to the n. That changes into, no, I can't multiply them out, so excuse me. It stays as 3n, 3 to the n. And now it's going to be 15 minus 6 is what? 9, 3 to the n. So I'm going to put that in here now. So this is just the red part. Oh, you underlined. Red part, red part, red part. Yes, Simon?
Would you know like the way you were doing the last question, I said 3 to the n?
So, another way of going about that, and basically you factorize out 3n, you're going to get 3n bracket, what's it, 3n plus 9. That'd be the way you factorized out the 3n at the start. You could have done that way, actually would have been quicker. Okay? So, what you can do next, that now that you have that done, what you can write in is this. It's going to be 4 times 3n plus 9, bracket 3 to the power of n, close bracket. Multiply this out. Okay? We're going to get 9n, 3 to the n. We're going to get plus 54, 3 to the n. And on the other side, we're going to get greater than, this is going to multiply in, and it's going to be 12n plus 36. Everybody agreed with that? And then I'm going to multiply that by 3 to the n. So I'm going to get 12n, 3 to the n, 12n, 3 to the n, plus 36, 3 to the n. I can't cancel the 3 to the n's on both sides. I don't know if they're positive or negative. Okay? So the fact that I don't know if they're positive or negative means I'm not allowed to cancel them. So I'm just going to bring everything over one side. Okay? So what I'm going to get is 12n minus 3 to the n. Sorry, 12n minus 9. Sorry, 9n minus 12n is minus 3n 3 to the n. 54 3 to the n minus 36 3 to the n is 18 3 to the n greater than 0. Now we're told that n is bigger than 0. So actually, as it turns out, we were guaranteed that 3 to the n is actually a positive number. Okay, so that's okay. In fact, it always has to be a positive number, because even if it's a fraction, it's a positive big number. Positive big number always turns it can never be negative. If you don't get what I'm saying, this is what I'm saying. 3 to the power of 0 is 1. 3 to the power of minus 1 is a third. 3 to the power of 1 is 3. You can see that all the answers are positive, so it's never going to be negative anyway. But just be aware of that. Now what we can do next is factorize out 3 to the n. And what we get is minus 3n plus 18. We need to look at this section here. This section here determines if it's positive or negative. So we need minus 3n plus 18 to be bigger than 0, because this is guaranteed to be positive. So this part here determines whether it's positive or negative. Bring the 3n over to the other side. We're going to get 18 greater than 3n. Do a switch. 3n is smaller than 18. All the numbers n smaller than 6. Any numbers that's smaller than 6 will result in that being true. Okay, so that's what we're asked for, wasn't it? Find the values, for what values of n greater than equal to 0, greater than 0. So all the numbers between n greater than 0 and n less than 6. It's going to be 1, 2, 3, 4 and 5. Okay guys, for homework